During the snowy season, if the temperature is low enough and the snowfall is heavy, the snowflakes will gradually accumulate. Snow cover occurs in many parts of the planet, and the depth of snow varies depending on climatic conditions. In extreme cases, the thickness of snow on the Earth can reach tens of meters. However, the deepest snow in the solar system is not on Earth, but on another planet, Enceladus. According to scientists, the thickness of snow on the surface of the planet can reach 700 meters, far exceeding the known snow cover record on Earth. With a diameter of about 505 kilometers, Enceladus is only 1/7 the size of the Moon, making it relatively small. Astronomers discovered it as early as 1789, and one of the important reasons was the extremely high brightness of its surface. In fact, Enceladus has one of the highest albedo natural satellites in the solar system, at about 81%. Because of this, scientists speculate that its surface is covered with a thick layer of snow and ice. To date, 2 probes have conducted close probes on Enceladus, confirming this hypothesis. The 2 probes are Voyager 2 and Cassini. Of these, Voyager 2 was only a brief flyby, while Cassini was dedicated to the exploration of Saturn and its satellite systems. Cassini arrived at Saturn's system in 2004 and embarked on a 13-year mission. Due to the depletion of energy, NASA crashed its control into Saturn's atmosphere in 2017 after it ran out of control. During the mission, Cassini sent back a wealth of valuable data to Earth, and it was on the basis of this data that scientists speculated that the snow on the surface of Enceladus could be as thick as 700 meters. So why does Enceladus have such a thick layer of snow? Located on the outer edge of Saturn's rings, Enceladus orbits Saturn approximately every 33 hours and forms a 2-to-1 orbital resonance with the outermost Titan or Dione, which means that when Titan makes 2 revolutions, Titan makes exactly 1 revolution. With a diameter of about 1,118 kilometers, Titan is much larger than Enceladus, and its gravitational pull has a significant effect on Enceladus. In addition, Enceladus's orbit is elliptical, which causes it to be subjected to periodic tidal forces, which in turn deform. Enceladus is rich in water, and its surface is mostly made up of water ice. However, due to its distance from the Sun, the surface temperature is extremely low, about -200 degrees Celsius, causing the water to freeze into a thick layer of ice. However, Enceladus's water is not completely frozen, because the tidal action causes the material inside to rub and generate heat. Scientists estimate that at depths of 30 to 40 kilometers above the surface, the temperature is enough to maintain liquid water, and the greater the depth, the higher the water temperature. In addition to heating the material inside, tidal action also exerts pressure on the ice on the surface of Enceladus. When the pressure reaches a critical value, the ice cracks, forming huge cracks that cause liquid water to gush out of the ground. Due to the high temperature and high pressure of the internal environment of Enceladus, the water sprayed out quickly vaporizes during the decompression process and erupts violently. These ejections of water quickly condense into ice crystals at extremely low external temperatures. Some of them escaped into space due to their high speed and eventually entered Saturn's rings, while the other part fell back to the surface of Enceladus in the form of snowflakes, gradually accumulating into a thick layer of snow. Due to the low gravity and extremely low temperatures of Enceladus, These snowflakes do not melt or compact, but accumulate in a fluffy state. As this process repeats, the thickness of the snow layer increases. To sum up, the deepest snow in the solar system is not on Earth, but on Enceladus. Of course, we can't yet know for sure if Enceladus has the deepest snow in the solar system, as there are many more similar planets, and our exploration continues.